All right, let's get right into it. Today, we are pulling the curtain back on a super common and honestly, a pretty dangerous vulnerability that could be hiding in your Node.js app right now. We're talking about path traversal. It's a sneaky one, but by the end of this, you'll know exactly how to slam the door on it for good. But first, let me just ask you this. What if I told you a single, carefully crafted URL is all it takes for an attacker to steal your server's passwords? The scary part? For way too many apps out there, the answer is a big, resounding yes. And we're about to see exactly how. Okay, so this hidden backdoor I'm talking about, what exactly is it? Let's break down what we actually mean when we say path traversal. At its core, path traversal is a trick. The attacker uses that classic ... sequence, the one that tells the computer, hey, go up one folder, to fool your server into grabbing files it has absolutely no business touching. It's like they've found a secret passage out of the guest room you put them in, and now they're just wandering freely into your home office, opening up your file cabinet. All right, this is where theory gets real. Let's actually walk through an attack, piece by piece. You're going to see how a feature that seems totally innocent, like, just letting a user download a file, can turn into an absolute disaster. So step one, it always begins with code that looks completely fine. I mean, we've all written this, right? You grab a file name from the user's request and you just stick it on the end of your uploads folder path. Easy. But here's the killer mistake. It's built on trust. It just assumes the user is going to give you a normal file name. And of course, that trust is exactly what the attacker is banking on. They're not going to ask for catpicture.jpg. No way. They send this nasty little string instead. That first ... says go up a folder. The second one says go up again. And just like that, they've broken out of the uploads directory and are now asking for the holy grail, the .env file. The one with all the database passwords, the API keys, literally the keys to the kingdom. So what does our naive little server do? Well, the code we wrote doesn't know any better. It doesn't check for anything malicious. It just does its job and mashes the strings together. And what you end up with is a file path that is technically valid. But oh my, is it dangerous? It's a direct route right out of the folder you wanted them in. And that's it. Boom. Game over. The server thinks, oh, you want this file? Here you go. And it happily reads the entire .env file and sends everything, your database connection string, your secret API keys, all of it, straight to the hacker. A full-blown data breach, all because of one single URL. Okay, that was pretty scary, right? But here's the good news, and it's really good news. We don't have to invent a solution from scratch. Node.js itself gives us the perfect tools to shut this down completely. We're talking about the built-in path module. It's going to be our best friend here. And you're not going to believe how simple the fix is. So look at this. On the left, that's our bad code, just mashing strings together. But on the right, we bring in a little hero called path.basename. What this function does is brilliant. It literally strips away all the directory junk, all the ... stuff, and gives you back only the file name part. Just like that, the hacker's entire attack is dead in the water. Go. So really, you've got two powerhouse strategies. First is the simple fix, path.basename. It's perfect for 90% of cases where all you want is a file name. But what if you do need to let users access subfolders? Well, for that, you use what I call the jail check. You use path.resolve to figure out the actual final path the server would go to. Then you just check, does this final path still start with my safe uploads directory? If the answer is no, you know they're trying to break out of jail, request denied. Simple as that. Okay, I know what some of you are probably thinking right now. This is all good to know, but I use S3. All my files are on a CDN. I'm not really touching the local file system, so I'm safe, right? Well, that's a dangerous assumption to make. Let's talk about some real-world traps where this thing can still bite you. And seriously, this is a super common thought process, but it's a trap. Using cloud storage is awesome. You absolutely should be doing it, but it doesn't make you magically immune. The problem is your server still has these little moments where it needs to deal with files on its own hard drive, even if it's just for a second. And this is where it hides, right in plain sight. Just think about your own apps. Do you have a feature that exports a CSV report? That report probably gets written to a temp folder first. Or what about resizing an image someone uploads? You probably download it from S3, resize it on the server, and then re-upload it. Or even just an admin panel that lets you view log files. All of these super common, everyday features mean your server is touching the local disk, and every single one is a potential backdoor.
So you see, it's not just about patching 1 or 2 lines of code. We need to think bigger. We need to change our whole mindset around how we handle files from users. So I'm going to give you 4, let's call them architectural rules. If you follow these, you're not just patching a bug, you're making your app fundamentally immune to this entire category of attack.
All right, rule number 1. This one's a game changer. It's the UUID renaming pattern. The rule is simple. Never save a file with the name the user uploaded. Ever. Instead, when you get a file, you generate a totally random ID for it, like a UUID, and use that as the file name on your server. Why? Well, a UUID is just a jumble of letters and numbers. It's physically impossible for it to contain a ... The hacker's weapon is useless before they can even try to use it.
Okay, rule number 2. This one pairs perfectly with the first. This is the map don't concatenate pattern. It's a shift in thinking. Instead of letting the user give you a file name in the URL, you make them give you an ID. So your URL changes from /download/someshadyfilename.pdf to something clean like /download/123. Your code then takes that ID, 123, and looks it up in your database where you've stored the real safe file name. The key is the user's input is never, ever part of the file path.
All right, on to rule number 3. This one's for a slightly different but still very common situation. This is the strict whitelist pattern. So let's say you absolutely have to use user input to load a file, like choosing a language, lang equals en, lang equals es. Instead of just taking their input and looking for a file, you check their input against a hard-coded list of approved values. You literally have an array that says en, es, fr. When a hacker tries to send some malicious path, your code just asks, is that string in my list? Nope. Access denied. Simple and foolproof.
And finally, rule number 4. This is the gold standard, the ultimate defense.
It's the CDN offload pattern. The philosophy here is stop treating your Node.js server like a file cabinet. It should be a brain, a logic engine. When a user uploads something, don't save it locally. Immediately stream it up to a dedicated file service like S3. Then you just save the public URL they give you. When someone wants to download that file, you don't serve it. You just give them the S3 link and let their browser get it directly. Your server's own file system is never even part of the equation. And if it's not in the equation, it can't be attacked. So we've seen how scary this is. But more importantly, we've seen how straightforward it is to defend against. So I'll leave you with this one question, a call to action, really. The next time you're in your codebase, do a search. Look for every place you're building a file path from user input, and ask yourself, which one of those needs a second look?